Welcome to this presentation on verifying SCION's Go implementation. Even though the SCION protocol has been proven to have strong security properties, its implementation can in principle still suffer from errors that may invalidate core properties of the protocol. To ensure the correctness of SCION's Go implementation, the programming methodology group at ETH has developed GOBRA, a program verifier for Go. GOBRA accepts Go code annotated with user-provided specifications describing the expected behavior of the program. We demonstrate GOBRA on a simple function that swaps the contents of two pointers. Later, we will demonstrate GOBRA on a short snippet from SCION's codebase. The first annotation establishes a precondition, restricting the values that can be passed as arguments to the function. In this case, they cannot be nil. The following two conditions establish the parts of the heap that are modified. Here, it corresponds to the locations pointed by val1 and val2. Finally, a post condition specifies that, by the end of the function, the contents of val1 and val2 have been swapped. GOBRA successfully verifies that the implementation satisfies its specification. Besides verifying the user-provided specifications, GOBRA verifies memory safety, crash freedom, and absence of race conditions. If the implementation is incorrect though, GOBRA fails to verify and rejects the program. Furthermore, it identifies the lines of code that cause verification to fail. GOBRA is under active development and is currently used to verify SCION's data plane. We now demonstrate a snippet of SCION's codebase on GOBRA IDE, our VS Code plugin that provides real-time feedback directly on the text editor. This simplified snippet contains the definition of the I8 data structure. It consists of identifiers for the ISD and AS of a given SCION autonomous system. Both identifier types are implemented as unsigned integers. The following function, IA from string, parses an IA from string and returns a non-nil error if it fails. This function is abstract, meaning that it does not have a body. This poses no problem to verification. GOBRA just assumes that every call to IA from string follows its specification, which is vacuously true in this case. Finally, we present the set method, which parses an IA from a string and sets the IA variable to point to the parsed value. We have already added annotations to specify the modified heap location. As you can see from the red text in the bottom left corner, GOBRA fails to verify the current version of the set method. This happens because the IA pointer may be nil. As such, modifying it may lead to a nil pointer dereference. One possible solution to the issue consists of surrounding the assignment to IA with an explicit nil check. GOBRA can now verify the program, signaled by the green label in the bottom left corner. This ensures that the shown program is memory safe. This example concludes our brief presentation of GOBRA. If you want to find out more about it, check out our website.